during your 5 minutes right now, one of the things that you can be doing that I will start to kind of have up here easily. If anybody wanted a Schoology yesterday, and if you went to the math page, which we don't use a ton, I used to use Schoology like daily, which is really weird that we just don't use it very much now. I have your answers posted. Okay, your responsibility. I'm trying this again, hoping that I can trust you guys and that you've grown up a bit more since I tried this earlier in the year. I had people just writing down answers in their math journals and not thinking about the work. At my training the other day, and we were discussing this with other CPM teachers and a trainer that we had there, he doesn't care about homework either, right? And like, I don't really grade your homework. When I do checks, it's for completion. If you are going to go on and just write down answers and not think, you're only hurting yourself. So I'm, again, going to try and hope that I can trust you guys to use this as a check, as opposed to, like, I'm just going to go in and write down the answers and never think about the practice. Okay, sweet. So.
When things like this happen, what I usually do is that this works for me, but so I like use it and then I have it in front of me and then I just do the work and I do the work knowing the answer
so that will bias your process. You shouldn't really do that. So I understand what you're saying, and I've done that before, but if you're trying to practice, can I do this? You should not look at the answers before, because it will bias your process. So you know what you're trying to get, it will bias your work. You know, like, you're just kind of tricking your brain into not thinking as hard. Why are we doing nothing? Like this, you guys could start your homework, you could check, like, we should not be sitting and doing nothing. Those papers aren't for you. Sorry, if you grab the resource pages, those are not for you. So. What do you mean, is it? What is it? Oh, no, sorry, I'll get our other. I have too many smart files open these days. I'm trying something new. I'm using CPM smart files, which I kind of like, but now I have like all of these open. So we're right now here. Hold up. Yeah, solving equations with fractions. You're trying to type overhead your notes or whatever.
I usually just do the
Yeah, it's better to have the topic. It's just better to have the topic, like, so that you know. And all right, go ahead and Any big issues? I would encourage you guys to start to check your work during AOR extensions so that I have that free time to help you guys. It's a little bit harder at the beginning of class because we are somewhat rushed. We fortunately have that time built into our day, so please utilize that. You don't have to come straight to me. Your peers are a great resource. So if you have any issues with your homework and you're like, oh man, Rachel is probably done with this, or Bilal did really well with this in class, or like Zach was answering questions, I think he's good. Go to those people and, politely, hey, would you help me with this? Can you explain that? Have you done this yet? Do you want to do this together? Like, I could not believe this question, but about a week ago, somebody asked me if they were allowed to work together on homework. Yes, please do that. Guys, we talked about this. I hope you're being sarcastic. So, you guys are allowed to work together on like almost anything. And even assessments, I let you work together. This is elementary. You have freedom. Break everything you used to know. All right. So now that we cleared that up, we gotta dive in. Hey, gentlemen, are you gonna be able to deal with class, or do we need to move? Yeah. Because it seems like we're just fascinated by eating chips. Look, yeah. Why are you guys turned around? Can you guys handle sitting there? If not, move. I don't want to have to move you. Okay, make your decision. Earlier in this course, we worked with proportions such as 3/5 equals 8 over x, and we talked about how to solve them. One method that always works to solve is what? What can we do to always solve a proportion? No, quit just regurgitating yesterday. Cross multiplication always works. However, however doesn't mean like but. However, sometimes we use other methods to clear out fractions and answer problems. So fraction elimination is not just used in proportions. Look, they said however too. It also applies to other equations with fractions. In this lesson, we're going to eliminate fractions using other techniques. So, Hannah wants... Come on. Okay, I'm still getting used to using their smart files. Hannah wants to solve 400ths x plus 1 equals 2.2. I think I need to do my calculator. We're not using calculators. What? We are going to look at how we can solve this just using paper, pencil, and our algebraic processes. So I'm going to give you a couple minutes. Hannah says, wait! What was the way that we learned to rewrite a proportion equation without fractions? Maybe we can use that idea. Now, I just want you guys to, whatever you think you would do here, I just want you to try your own first. Like you should know, I go kind of rogue from CPM occasionally. Don't pay any mind to what Hannah's talking about first. Whatever you would try to do to solve this without a calculator. Yeah, some people are realizing you gotta number more pages in your math journals and stuff. We're starting to push. But do that on free time. Do that when you're killing time.
I don't have any time to kill time.
Oh, wait.
I agree. I have 3 things happening this evening. I bet that we would all agree on the first step. What would you do first here? Mina? Get rid of that 1 with subtraction. So we then get to here. And I think most of us probably got it. The question is, what the heck do we do to get x by itself here without using a calculator? I really need to get out cards. Rachel?
So what I did was, well, I know that 4 times 2 equals 12, so I just did 0.04 times 30, and then did 0.5.
so you just kind of like looked at what you know about how the numbers relate to each other. Interesting. Yes, you recognize the 4 goes to the 12. You're right. That in a way, that's like a guess check method. When you derived your solution, you actually used a different technique that you don't realize. I don't like these decimals. I could do anything I want to either side. Alex?
If you divide it, then since you're dividing by can be decimal, but you want to divide it by can, you need to move the decimal from the one you're dividing, the one that you're dividing. Well, you're smart. You need to move the decimal for both. So if you were to move the decimal in 0.04 to 4, since that can't be a decimal, the other one can.
How do I do that, though?
You would multiply by 100 or so.
100 multiplied on both sides will turn 4 hundredths x into just 4x. Now, check this out. Now I need to write it on both sides. Sorry, I'll do that before I move on. If I had rewritten this as 4 hundredths x, and it could equal 1.2 or whatever, it is the same thing. But then what I think about is, well, I don't want this in fraction form. I'd like to clear the fraction out of here. So that's how we get to the point of, to get rid of a denominator of 100, I multiply by a numerator of 100, right? And we could multiply by 100 over 1, and then clear out my 100 in the bottom, and we get to 4x. Can anyone think of an efficient way to clear all of the 4 hundredths out of here and end up with just 1x? Moving here?
25.
Nope, I'm not doing the 25. Because then you're going to explain it in a weird way, maybe. But
No.
you're right. You are right. But I want it in a different way. Tyler?
The denominator.
So,
with that.
You're right. Just hang on to it. Hang on to it.
okay, so you find a way for, start off with what you did at the beginning, which was the 400x, 400x, and then multiply by 100, and take the 1.2 and multiply it by 100. So you have 4x on one side. And
I don't want 4x on one side. I want it all to clear.
And 120 on the other side, and then just divide both sides by 4 to get 1.
But I want to do that in one step. Nina?
Times it by 100 over 4.
If 100 on top clears my 100 on bottom, to clear a 4 on top, just put a 4 on bottom. And that's why Bouvendier said 25. Because 100 over 4 is 25. So really, we're multiplying by 25. Now, you could, and I like the process of multiply by 100 and then divide by 4. That's a perfectly fine process. But I wanted to show you the shortcuts
Shortcuts are fun.
to get all the way to just x equals. Now, the problem is I now have to do 1.2 times 25, which if I don't have a calculator, but I don't really actually. Because if I still think, I'm just trying to show you guys how this is still easier than, if you think about it in fraction form. What's 1.2 times 100? 120. What's 120 divided by 4? 30, and that's an easy way to get there.
Can't you cross simplify at the beginning? 4 divided is 0.3 times 100.
What?
Because if you cross
Oh,
simplify.
because you could simplify.
We're gonna look at we're gonna look at another method. So this x is 30, right? We're gonna do this in another way. 4 hundredths x is like if I had 4x divided by 100, right? So if we instead say 4x divided by 100 equals, what do we have on the right side? 1.2, right? How can I write that differently, make life easier?
1 and 2 tenths, which is 1 and 20. What? Yeah, but in 20 hundredths. And then that would be 120 over.
Yeah, okay, so that's where we want to go. 1.2, we can really write as 1 and 2/10 or 12/10, which we can think of as 120 over 100, which, I mean, that is still equivalent. If you go all the way to here, then you can easily just say, okay, what does x have to be to get it to be 120? If this didn't work out as well, and you just say maybe had a fraction that didn't have the same denominator, cross multiply. A lot of ways to deal with these. Okay, what I'm trying to get you to see is there's not one right way, there's not even 2 or 3, there's like a bunch, right? A plethora, if you will. So, move on and try this. So, we have a lot of different methods, but we know that one of the first things we want to do is combine the constants, right? The numbers, not the variable values. But we want to get rid of this 0.6 or get rid of that 250. So with your partner, try each of these, rewrite it so it's easier to solve, and then if you want to, go ahead and solve it, if possible. Oh, sorry, a little bit of vocab before we move on and I forget to do this. When we looked at like 100 over 4 compared to 4 over 100, if I look at like 3 over 2 compared to 2 over 3, we talk about the fact that how that multiplies to get 1, because this becomes 6 over 6. What do we call blue fraction compared to red fraction? What's their relationship? Starts with an R. They are reciprocal. Remember, when you flip, reciprocal. Reciprocal. Okay, so just a little bit of vocab reminder.
When you cross multiply, how do you know which one is on the top?
What do you mean?
Or bottom?
That's not cross multiplication.
I know,
That was
I know,
straight
that's
multiplication. So you had
When
like,
cross multiply.
let's look at C. I hate writing a regular pen. We had 2x over 3 equals, and we could make this 30 over 1. So then we just rewrite this as an equation. 2x times 1 is 2x equal to 30 times 3 is 90.
Oh. Okay.
So that's the same equation. Just rewritten.
Okay. Yeah.
Now, here's what we actually could have done instead. Oh, look, it's like a railroad sign. If I want to get rid of the fact that this is a fraction, multiply by its denominator. Right? That gets rid of it being a fraction. Same thing as cross multiplying. Because this isn't even a fraction. So the only fraction I have to deal with is over there. That's why it's the exact same thing. So you understand what?
What? I mean,
What?
I just figured it out. I don't know if I did it right because I just thought about it.
That's what I did. But no, if you think about it, look. So you know how, did you convert them into a fraction? You got face them.
Well, I just
really
subtracted
easy then.
0.6 and then.
Yeah, I know. So then they,
I was thinking about it. I got it, and then I lost it.
yeah. Negative 6.5.
So Bilal, you were just chatting with a classmate about turning this into fractions, and then it's easy.
Well,
What do you mean?
it's also kind of a guess.
Okay. What would you do?
So I converted 2 to 2 1/10, and 16.8 to 16 8/10. So then I saw that since they both have the same denominator, and that has 8, so I thought maybe if I multiplied by 8, and so I checked 2 times 8 is 16, and 1/10 times 8 is 8/10. So.
Yeah, another thing I can do here is say, well, like improper. You guys know I like impropers better than mixed. Improper, still relating the fact that we have the same denominators. We really know that the x is multiplying up here. This is like 21x divided by 10, or 2.1x is 2.1 times something. Right? So if I look at 21 times something has to equal 168. We'll all recognize it. Oh, well, wait. I can just, 8 times 20 is 160. 8 times 1 is 8, and that can work out really easy. Another thing I knew right here to get this out of being fractions, though, what could I do on both sides to get rid of fraction form? What's happening on both sides that makes it in a fraction? It's dividing by 10. What do I do to undo that? If I multiply by the denominator, I clear it. Right? So that now gives me 21x equals 168. Guys, one of the biggest struggles that middle schoolers have with equation solving is there's so many right methods, it's hard to know if you're doing the right one because mine might be different than what you did, but we get to the same place. So please realize there's a lot of methods to get there. I could then, you want to tell me what I'm going to do next?
No, I was going to say what I did.
Okay, hold on. So here, to finish this out, we would just divide by 21 and get that x is 8. Now what'd you do, Will?
So what I did is it didn't really involve fractions at all because I knew 2 times 8 is 16.
Yeah.
And that was very close.
You just solved the
And
number
then
relationship?
1.8 and then add the 0.6.
Nice.
That's what I did.
Yeah.
The
Now
only
again, if you
math-
had a calculator,
Yeah, the only math I kind of had to do was 2.1.
yeah, just checking that. All right, look at, anyone want to talk through B? I'll leave it at that.
That's exactly what I did.
Ian, what'd you do?
Okay, so I thought it's 100 times something, and then it has to be something plus 250 equals negative 400. So then I got negative 6.5 times 100 equals negative 650 plus.
So how? So like what? Like how'd you get there?
It was simple.
But talk me through how you got there.
Okay, so I added 400 plus 250, 650. Then I was like,
No, wait, why'd you add those?
Yeah, what?
okay, so
I haven't disagreed with anything you said.
I know.
I'm just pushing.
So it's negative 400. I thought since it has to be 100x plus 250 equals negative 400, it has to be something negative plus 250 equals 400.
So essentially, you were saying this has to be.
Negative 6.
So really, what you did,
Yep.
because you don't like writing out work, I doubt you actually did it. But this is what you did.
Yeah.
That's exactly what you did.
And
Then I'll let you go.
And then since it's times 100, it was negative 6.5.
So he says, well, if really that's times 100, my value here should be 100th of my value. So what you actually did was that you followed the algebraic process, but in your head, I don't even want to know what it looked like. I mean, I'm sure it's scary, but you got there, right? Get comfortable writing out the process. It's not always this easy. Actually, hand on the book, it's never this easy. It's gonna be complicated. You gotta get comfortable writing the process. So even if you did it in your head, please write this out. Please, beg of you. And we do get x is negative 6.5. Rachel. Hold on, let me clear this ink real quick.
My mother yells at me because I don't show.
Rachel, what'd you do?
So I guess Well, I just made it so that it was 2x equals 10.
Okay, so I did this on purpose.
Yeah,
So hang on for a moment.
Oh, but the x goes into 2.
If we have a quantity, right, x, and we have two of them, and then we divide that by 3, right? That's what they told me. We have 2 x's, and we divide that into 3 groups, like 2 pizzas, 3 people, something like that. How, or really, I should phrase that differently, is that different than 2/3 of the pizza?
Yeah, I've been trying. I've tried to
Yeah.
the x
X
has to
goes
be
into 2.
x has to be moved up next to 2.
I have 2 pizzas, right? 2 x's. I'm going to give them to 3 people. So, because one's pepperoni, one's sausage, can I please make it? Because the people talking are the people that need to hear me. So I give each person 1/3 of the pepperoni pizza, right? A, B, C, or whoever my people are. Then I move on to my other pizza, and I give each person 1/3. Sorry that they don't look the same size. How much did each person end up with? 2/3 of a pizza, right? Like 2/3 of a pizza. Is that different than 2 pizzas divided by 3?
Yeah.
Yes.
No.
Wait.
No. Yes. No.
It's the same thing. You get the same result.
This is exactly the same as this.
Okay.
Oh, you taught me that
Yes,
yesterday in
the
math.
math counts with the negatives, and you can move it anywhere in the
I still got the right
Now,
answer.
here's where it's different than the negative. That is very different. No, we'll just stop here. So I don't want to overload you guys. So this is exactly the same. We'll get there. This is exactly the same. But, depending on how you want to approach it, the x on top could be a lot easier than putting the x out to the side. But if it has the x out to the side, you can put it in the numerator. So I had somebody arguing with me like, well, that x is part of both. Not really. The numerator is 2x, the denominator is 3. Even if the x was out here. So, Rachel, take back over. Dude, how many times?
I have a question.
Yeah.
So I somehow I got to 2x equals 10. Like I thought I could just like get rid of the 3.
I know your
divide by
mistake.
10. But now that I'm thinking about it, do I have to multiply it so it would be 90?
You have to multiply by 3 to get those.
9 equals 2x.
Wait, what?
Oh, no, they're just getting confused. I was about to freak out. There's no way that we're out of time.
I know. We talked for that long.
Because time flies when you're having fun. So, hey, hi. And other people in the hallway. When all we belong. You can't ask a question and ignore me, but I love that Rachel, Amy's trying to tell you. So, explain to everybody. You can still answer, but I want you to explain to everybody. Bilal said, why did we multiply by 3 over 1? And I don't know if you were confused by why I only did times 3 over here. So why?
Because you're dividing 2x by 3, and so to make it disappear, you have to multiply. Yeah.
Yeah. If you have 1/3 of something and you triple the third, you have the whole of something. So if we triple the 2/3, we end up with 2. And we could get there through cross multiplication just, or sorry, not really cross multiplication, cross clearing. I said that wrong. We have the same values on top and bottom. We know that this would actually become 6x over 3, which is how it becomes 2x. But you can also, this is not cross multiplication. I want you to see, this is looking at cross canceling, quote unquote. It's not really canceling, it's reducing. It's simplifying this. It's this. It is. It's this. I don't like that it's called cancellation though, because it reduces to 1. It doesn't cancel, it reduces. But if you don't like that, just solve it. Get down here. So x is. Now get comfortable showing the work. We divided by 2. Please show the work. If you turn in a math journal with just answers, it will be not progressing. And our last one, which really honestly could have been our first one to help us, but sometimes we do this out of order to give you some mental discrepancy before we get to the easier ones. Yes, my goal in life is to make you mad. No. That's a lot. I'm being sarcastic. You guys, what is my goal? What's my goal?
Make you
Make your life easier.
I thought it was to be happy.
My goal is to make your life easier through math, right? My goal is not to make your life harder.
So you don't want that's the point of that.
I'm being a good person. What do I do first here? I still haven't got. How'd you guys get away with this for so
No,
long?
wait, I have a question.
Question.
But if we go deeper and deeper into math, wouldn't we have more questions and wouldn't that be a pain?
Yeah, but the more you understand, the easier the day-to-day life is going to be. Like, the only reason I had the confidence to buy a house is I understood the mathematics behind it. Very few of my friends own a house right now because I realized paying rent is throwing away money. You have to, like, yeah, I need to live somewhere, but if I get nothing, like, when you pay rent, you get nothing at the end, right? You move out. That's what you get at the end. When you have a house and you pay money to live in your house, at the end, you sell your house.
Or you ruin your credit by like not.
Right, but that's why you check your finances and make sure you're good to live where you're going to live. So, Piper, ironically, you're first on the stack. What do I do first here? Oh, the first steps.
I haven't even looked at the problem yet, so that's why I don't
Okay.
know.
First step, always combine like terms if possible, right? That's what you're doing. Say again what you told me to do. You are combining like terms. These are like terms, right? They're both constants. Although they're on different sides, I can combine them by removing it from over here, dealing with it over here. Now we have x over 5, or a fifth of x, is -7. So now, Tyler.
So now I was thinking, what can I divide by 5 to get -7?
Nope, you're thinking too hard.
So I just multiplied the 7 by the 5.
Now you're talking.
Because what I did was I just put like the 1 under the 7.
Yeah.
And then just kind of cross multiply it. And
So, here's the funny thing that we're trying to get you to see. Cross multiplication is what we're doing here. Sorry. Thank you. Don't know. Should have been blocked, but when we cross multiply, give me your eyes. Put your pencils down. Give me your eyes. Put your pencils down. When we cross multiply, we're used to a fraction equal to a fraction. Any number can be a fraction. So when we made the -7 into a fraction, all that meant was this cross multiplication doesn't do anything, because times 1 doesn't do anything. So all we are really doing in cross multiplication is trying to get rid of denominators. When we have two different denominators, cross multiplication clears both. When we have only, and even saying that statement is a lie, when we have only one, we really have two denominators, there's a 5 and a 1, but we don't really care about that one, so we have one denominator to get rid of. Right? I don't need to get rid of this one. So to get rid of it, we just multiply by it. That's what cross multiplication is doing, but on both sides with two different numbers. This is a nice easy method to get rid of our division by 5. So we multiply by 5, and we can put it over 1 if we want to make it fancy. We find out that x is negative 35.
And to check your math, you just divide it by 5 and you still get it.
We plug back in to check. Any preguntas?
I don't know what that means.
Questions?
She told us this.
My,
Like, what do you mean?
Now, we have two different denominators. So, hold on, just quit your whining, mommy. Follow the process outlined here. If you have a book, it'll make your life easy. Otherwise, I'm going to blow this up a little bit.
So you just multiply. So that one.
So, you're on your own. I'm not doing anything with you for a couple minutes.
What? Why would you abandon us in the middle of the highway?
Life is
That's on him in my head. You don't like it?
Oh my god, I gotta get it back to the chat. I've been writing all this crap.
We need to make up a really weird, like, nobody else understands, like, what snake molted in your Cheerios this morning? Or something off. So, two phrases that they come in the morning and they're in Goldring's room. Two things I've said to them that they've been like, what are you talking about? Was who peed in your Cheerios? Which means, like, why are you in such a bad mood? Like, what could have happened that you're in such a bad mood this early? And if it was a snake, it would have bit you. So I gotta educate you guys more than that. So if I was like saying like, where are the graphing calculators? I can't find they're right here, right? So that expression means it was so close. If it was a snake, it would have bit you.
I know.
There you go. There are your old school phrases for the day.
used it wrong this morning. I sat in their chair and she said, it was so close to the name of the video. My mom said that I confused my friends by saying stuff my mom with
What?
my mom.
Oh,
I'm telling you. So I'd be like,
I was wrong.
I don't want to tease it.
I'll go ahead and place a wager. I'll give a sucker to whoever who can clearly, you don't even know what I'm asking, explain what we end up finding out here and apply it to a new problem. So take time. We have like 8 minutes, guys. Take time. You're following the directions. All you're doing right now is following the directions.
All we have to do is follow the directions.
Did you ask it in Blah yet?
Exactly. See, now this is how we can work.
You have to be able to explain why. What did you make happen? Like why? And you might even show a step between here and there to explain why you chose LCM. Didn't substitute multiple. So we're not plugging in facts, we're literally saying what would x divided by 3 times 3 be? What would x divided by 5 times 3 be? Which if you make 3 a fraction, you could just say 3 times the top of there, 3 times the top of there.
They make you do something and then look at it.
Because it just triples each value. You would just
We have all the answer. Oh, that's what we're trying to do. That makes so much sense. No, it doesn't.
What is 48 times 5?
No, I still got the same thing.
Isn't the equation 60?
No. Is this better? No, it's better and it's better because I don't know how to figure out. I know that, but I don't know how to do it.
interacting with you right now.
Yeah, but you asked a question, is this better on the board, so I answered it. Yeah, this is better.
Oh my god, I just limited one fraction. So now I need to like
All right,
Oh my god. Go.
You said you were interacting.
Bouvendier, come up here. Take us to school.
So,
I don't think any of those are right.
Any places with Bouvendier, he's your teacher now.
I do, sort of. Okay.
Mr. Groovy at the top.
Whoa, 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 whoa! You erase my work?
Well, I'm sorry.
Okay, so hold on.
This subject is to tell the
how you got there. You can't just jump over it because we don't all understand what you understand.
Okay, so I was trying to find the LCM of 3 and 15 to make them whole numbers.
Hey, back up. We don't know that yet. What happened with the 3? What happened with the 5? Alright, sit down for a second.
Yeah.
Or stay there, but I think Boo jumped too quickly, and he's not, like, outlining what's going on. So, when we, and you're coming back, so don't get too comfortable back there. When we multiplied by the 3, what happened? Was that good? Did it do anything productive, Tyler?
Well, it took the x over 3 and it made it 3x over 3, which now it's just
That would just be x, right?
yeah.
But this is still a fraction.
Yeah, but when you multiply it by 5, that one is
Right.
Oh, so if you multiply both of them.
So then, we multiplied by 5.
And it,
Did you say I don't like this teacher? So, moving do come on back up. Do we all see that multiplication by 3 would clear out the division by 3? Multiplication by 5 would clear out the division by 5, but each of them then still leave another fraction. Are we good there? We see that. Moving.
Oh, I do like it.
Okay. So, can I erase your or and replace it with a multiplication too?
I would love it if you would. Or you could replace it with an and if you want. So what we've now realized is in order to clear, you can still look up there because he's doing good work. In order to clear the division by 3, we had to multiply by 3. Hey, just erase 3 and 5, rewrite the whole thing. In order to clear the division by 5, we had to multiply by 5. So in order to clear both at the same time, you do both at the same time. Boo, so we get.
So, we get 5x. But it would look better if you could see it.
I have no idea what's going on. I don't either.
So here, do this. Alright, so we all saw this, we all did that, whatever, great, awesome. I'm going to clear this ink. It's fine because we're not really uploading those like we used to. Our original, I'm just trying to do this fast, x divided by 3, x divided by 5 equals 16.
Yeah. Okay.
So here, let's do this so we can see that we're doing it on both sides. Just change colors. So on both sides, so Bougainville was talking to me back in the back, and he said, I chose the least common multiple. Right, pull that back out. When we multiply, we go up. 3, 6, 9, 12, 15, 5, 10, 15. 15 is our least common multiple from both. Or it's just 3 times 5. We can also just get there.
Oh, so you think you do 3?
That is going to create, and it distributes, right? So that multiplies with each piece. So Bouvindier's showing that out really well. Damn, that's going to be a big number. Let's, for sake of time, we got to skip steps. So 15x divided by 3 would be what? 5x, right? So go ahead and write it. What about 15x divided by 5? 3x, right? The other multiplication here. Then 16 times 15, who's got it? 16 times 15, I don't know, what, 240? Okay, sweet. So we get 8x equals 240.
I was double the answer. I have no idea. Oh, I got one.
So your answer should be 30, right? Hey, so everybody stop talking, please. I'm going to explain this one more time while people write it. Seriously, please don't talk. You have peers that are confused. It's really rude if you get it and you decide to talk right now. We could have, step by step, cleared out the division by 3 and the division by 5 by first multiplying by 3 and then multiplying by 5, but that would be annoying. So instead, at the same time, we'll multiply by 3 and 5. Now that is multiplication by 15. So we multiply by 15 on this side and 15 on that side. That really gives me 15x over 3, which is 5x. That really gives me 15x over 5, which is 3x, and this is a constant value. We then combine our like x terms, and then we want 1x instead of 8x, so we divide by 8. Now, Monday, we'll switch it back into CC2. So, we'll be in chapter 7. Have a good day, guys. Thank you very much.